Alright, Honors Algebra 2. Here is a video that I'm hoping will help you out with calculating the speed of your roller coaster at different points, as well as to calculate the end of the ride scenario. Now, I don't have any particular ride picked out, so I'm going to start by just making one up. I'm going to try to make it as nice as possible, but if the numbers get ugly, then they get ugly. So I'm going to go ahead and start. Let's start by just going to Desmos and just kind of picking out where we want our roller coaster to go through. Like, I want to start it at 0, 0, which would mean that I need to have at least a factor of x. And then let's have it go through x equals 2, so x minus 2 as a factor. And then let's maybe have it bounce at x equals 6, so let's make x minus 6 and make that squared a factor. Okay, looking pretty good so far. Let's see here. And then let's make it a little bit smaller. Like, let's make it so that it looks like I'm going to have some pretty big jumps down here at the bottom where it's been down really low. So let's make our bending coefficient like 0.1 maybe. Just kind of making this up right now. I like it so far. Maybe put a negative in front, see what that does. Ooh, cool, I like it. And then maybe do something where I want to move it up now, so maybe start it at positive 5. I like it. Cool. Okay, so let's work with this. Let's kind of see where this takes us, and then we'll kind of see what would happen if maybe we use a different roller coaster. But let's use this one for right now. Alright, so let's see. Looks like we're going to start it. I'm going to go ahead and start mine at the y-intercept, so I'm going to start mine at 0, 5. Here's going to be a maximum. We've got a minimum here. Another maximum. Ooh, I like that. That turned out really well. And then here's going to be our stopping point. And I'm going to go ahead and use all of this. I'm just going to take a screenshot, Command-Shift-4 if you ever want to take a screenshot. And let's just put this into OneNote so we can refer back to it as we make some of our calculations. Okay. So in OneNote, let's insert that picture now. Here's that screenshot. Cool. I'll make it a little smaller here. Alright, I think we are in business. Alright, so let's start doing some calculations here. And bear with me, my handwriting not as used to the Wacom tablets as you guys are, but I will still try my best here. Okay, so let's first kind of look at this first part of my roller coaster where I know that I'm going to be traveling at a constant 1 meter per second. So that's going to get me kind of up to the top of this first hill. Now, at that point, remember the formula we're working with for calculating speed, v sub f minus v sub I is equal to a parentheses t sub f minus t sub I. So now let's calculate that for our first interval that we're going to do. So that will be this interval that I'm going to do in blue here. This will be the blue interval, which will go basically from that point down to this point. Okay, now, final velocity, I don't know. My initial velocity, I'm traveling at 1 meter per second when I get to the top of that hill because of going up at 1 meter per second. That's where I had to use some belts. Now, my acceleration due to gravity, that would be, in this case, not negative 9.8, so you're probably wondering what I was doing there, but positive 9.8 meters per second squared. So we'll put a positive 9.8 there. My final time is at 3.686, and my initial time that I'm going to subtract is 0.814. Okay, so really what I need to do is I need to take 9.8 and multiply by all of this in parentheses, and so let's see where that gets me. So 9.8, we'll switch over to graphing calculator here, 9.8 multiplied by, let's see, we had 3.686. So 3.686 minus 0.814. So 0.814, which gets me a value of 28.1456. So 28.1456. And then you still have your v sub f minus 1 on the left side. And then to solve for your final velocity, just add 1 to each side, and you get 29.1456 meters per second. Now, depending on how high your roller coaster goes, some of you might get some very high speeds. Just kind of keep that in mind. That's perfectly okay. Just kind of know that that's something that you're going to have to watch out for, especially at the end of your ride. You might even have to, for some people, increase the distance so that you can stop your ride in real time. If you do decide that you need to increase the distance, increase by increments of 50. So we'll talk about that later. For right now, let's go ahead and calculate the speed when we get to the top of our next hill. So this will now become my green interval. I'm going to go from here up to here. Okay. So once again, do not know my final velocity. My initial velocity is what I just ended with, 29.1456. Now, acceleration due to gravity, I'm going up, so gravity is working against me, negative 9.8. My final time was at 6 seconds. My initial time that we just ended at was 3.686. All right. So, left side, let's just leave that alone for right now. And let's go ahead and calculate the right side. So, now we're going to take negative 9.8. And multiply by parentheses. We're going to take 6 minus 3.686. So 6 minus 3.686. And we get negative 22.6772. So a negative 22.6772. I think that's what it was, 0.6772. Cool. Now, last step here, we're just going to add 29.1456 each side. So that should give us a positive value, which will be good. So let's see. We're going to take that and add 29.1456. Gets us a speed when we get to the top of our second hill of 6.4684 meters per second. So 6.4684 meters per second. Double check that. Cool. All right, so there's your speed of your first two intervals. Here comes your third interval. And again, your roller coaster being different, you might have to do this more times than just what I'm doing. So, here we go. Now, my final velocity, once again, minus my initial velocity, which is that 6.4684, which I am carrying over, is equal to, now I have gravity working for me again, 9.8. The interval we're looking at, we're going from 6 seconds here down to 7.163. So 7.163 minus 6 seconds. And let's once again just focus on the right side of the equation. So I've got V sub f minus 6.4684 still on the left side. Right side, you take 9.8 and multiply by 7.163 minus 6 is 11.3974. So 11.3974. See, yes. Okay. And then last step here to find your final velocity, and this will be for the end of the ride now, is again to just add over that initial velocity. So add that 6.4684. So we're adding that value up here. And so our ride at the very end of it is going to be going 17.8658. So 17.86. Oops. 17.8658. And that's in meters per second. Now, at that point, remember all of these speeds, if you really wanted to, you could go back and convert those into miles per hour. Don't necessarily need you to, but just keep in mind you could if you wanted. All right, so there's calculating speed. That's kind of how you would do that. Now, obviously, in some places, if you would need to put in tracks, you would obviously need to, put in your zero for your final velocity and go ahead and calculate your initial or your final time from there. What I might do, I might make a separate video showing you that, but this one worked out really nicely just to kind of show you the basic calculations. Okay, now, at this point, let's do this. Let's go ahead and calculate the end of ride scenario. So, what we need to do, here's where we're going to have a different formula. We're going to say that our distance, d, is equal to our initial velocity multiplied by time plus 1/2 acceleration multiplied by t squared. Now, a lot of this stuff you already know. For instance, we already know that d, I told you to make that equal to 50. In other words, you need to be trying to stop your ride in 50 meters. Now, my initial velocity here is just what I finished off with, that 17.865. Still don't know what t is, so t plus, I'm going to take 1/2 our a value, which is negative 9.8. These we're going to assume that we are slowing down due to gravity, and then there is t squared. At which point, let's kind of simplify this just a little bit. The first thing I'm going to do, on the right side of my equation, I want to put it in standard form. So I'm going to go ahead and take 1/2 multiplied by negative 9.8 is negative 4.9 t squared. Still have my 17.865 t. And then to get one side equal to 0 so I can start to solve, I'm just going to subtract 50 from each side. That would get the left side to be 0. Right side just puts a minus 50. So here's the equation I'm looking to solve. Negative 4.9 t squared plus 17.865 t minus 50. Okay. Now, in this case, and pretty much for everyone, this is where you're most likely going to have to use quadratic formula to say that t is equal to, take the opposite of b, a negative 17.865, plus or minus the square root of b squared, which would be 17.865 squared, minus 4 multiplied by a, which is a negative 4.9, multiplied by c, which is negative 50, all of that divided by 2 times a. So 2 multiplied by negative 4.9. All right. At this point, what we need to look to do, I would probably try to simplify what's underneath the radical first. So, starting with the 17.865 squared, so let's start by typing that in, 17.865 squared. All right. And then we're going to subtract 4 multiplied by a, which if you recall, we had a was a negative 4.9, multiplied by c, which if you recall, was a negative 50. And we type all that in, and here's what we get. We get a negative 660.842, which here's what that means. It means my roller coaster is going too fast at the end of it in order to get it to stop in a reasonable time, which means that you really need to kind of play around with this equation now, meaning we need to kind of find a distance that's going to work for us, which might mean changing the distance to maybe be a little shorter, like negative 25. And we got a little closer. Maybe instead of stopping in 25 feet, or 25 meters, let's maybe try 10 meters. And there's a positive value that I'm looking for. So, here's the deal. For those of you struggling to get your acceleration to work out, what that might mean is that you might need to make the distance that you need to stop either a little bit longer or a little bit shorter, which really just means playing around with this last value, your c value. So here's what I'm going to do. I'm going to change my c value, as you can see, to a 10 meters. Now, once again, that's just kind of depending. I want you to try to keep it under 50 meters. Now, I said put it to exactly 50 meters, hoping that that would work out for most people. But depending on the speed of your ride, as you can see, I had to play around with mine for a little bit. So just play around with the C value, especially with what's under the radical, until you get something that's positive. Now, I could keep playing around with that to try to get it to a different value if I really wanted to, but I think that's going to work out well for me. So here's what I'm going to do. I'm going to go back. I'm going to change my distance that I'm going to stop in to be 10 here, which means also changing it to be 10 here. Also means changing it to be 10 here. So now what we're going to say is we're going to stop our ride in 10 meters. Okay, so we've got a negative 17.865 plus or minus the square root of, and try to keep as many decimals as possible. So 123, I'm going to go to 3 decimals, 123.158. 123.158. All of that divided by 2 multiplied by a, I'm going to go ahead and simplify that as well, is a negative 9.8. Okay, so let's do this. Let's take square root now. So we're going to take square root of our answer here. So square root of this right here, which gives us 11.098. So 11.098. Okay. So negative 17.865 plus or minus. We said that that was a, let's see, 11.098 divided by negative 9.8. And now let's see. I'm going to go ahead and split this up. So we're going to take negative 17.865 and add 11.098 to it. We're also going to subtract it. And both of the times we're going to divide by negative 9.8. So let's go ahead and take our negative 17.865 and let's start by just adding. So we're going to add that to this, gets us here, then divide by your negative 9.8. So one possible solution here would be that the ride could stop in 0.69 seconds. Okay, let's try the other one. So negative 17.865, this time minus our 11.098 here, and then take that and let's divide by negative 9.8. And another possible scenario for my time is for the ride to stop in 2.955 seconds. Now for me personally, I'd rather stop over the course of a few seconds rather than a split second. So if it were me, what I would most likely do is I would go ahead and use this time right here of 2.955 seconds. So for me, the t that I would use would be that right there. So 2.955 seconds for my end of ride, and that's what I would use in my calculations. Okay, so really this video hopefully will help you out with calculating your speed and your end of ride scenario. So keep in mind with speed, make sure you're carrying over that initial velocity, make sure that you have any belts built in where you need those, and that will get you through calculating the speeds everywhere. Also, when you get to the end of the ride, some things to watch out for. Although the distance it tells you to use is 50 meters, you might need to change that just a little bit. For me, what that ended up being that worked out was 10 meters. So really just kind of play around with your discriminant. Keep in mind your discriminant, which remember discriminant is just what's underneath the radical, b squared minus 4ac. Your discriminant needs to be positive. Well, really just needs to be non-negative. But in order to have a good set of solutions, this needs to be positive, so that way you can get those real solutions that you need to be able to stop your roller coaster. So what that really means is that this value of C, you might need to kind of play around with that until you get your discriminant to be positive. Once you get a positive discriminant, really the rest of it should work out very well for you. So for those of you struggling to get your end of ride figured out, just kind of play around with your C value to figure out where you get a positive discriminant, and then use that in your quadratic formula in order to get your acceleration. Alright, that is it for this video. I am going to try to make a second video for you guys tonight to show you how to calculate your belts if you would need those, and that's that. If you're presenting tomorrow, make sure that you've got all of your presentation stuff ready to go. I will not calculate, or I will not take your project until Tuesday unless it's done on Monday. So for those of you presenting on Monday, at least have your presentation ready to go, and then make sure your project is ready to hand in on Tuesday's class. All right, that is it. Have a good rest of your Sunday, guys, and I will see you in class tomorrow. Also, just as a side note for class, make sure that you are meeting in the little theater. We are going to start class in there, and we are starting right away. So please do not be late. All right, have a good one, guys.